Yeah, so we'll first do a few concepts of tangents and normals and then do JEE Main PYQs. So given any curve like this, y equal to some f of x. So if you draw a line in such a way that in the neighborhood of a point called P, so suppose we choose a point P, we draw a line in such a way that in the neighborhood of P, this line cuts the curve at a unique point, but it can cut other portions of curve at any number of points. So this type of line is said to be tangent at P. This line is said to be tangent at P. So if you have to define a tangent, how do you define it? So a line L is said to be a tangent to the curve y equal to f of x, a tangent to the curve y equal to f of x at the point P. At the point P, if it cuts the curve, at a unique point, if it cuts the curve at a unique point in the neighborhood of P, in the neighborhood of P. So to call it as a tangent at P, it should cut the curve at in the neighborhood of P at only one point, but it can cut the curve at any other point also. It doesn't mean that it should cut at only one point like we do in a circle. It can also cut the curve at multiple points, but only thing in the neighborhood of P, it should cut at a unique point. Then this line can be called as tangent at P. So is that clear?
Yes,
So
sir.
this is a definition of tangent. And coming to normal. So any line drawn perpendicular to the tangent at P, to the curve y equal to f of x, is known as normal at P. So is known as normal at that point P. So if you have to draw a normal, I'll just draw it in green color. So this line. So a line drawn perpendicular to tangent at P. So this line is said to be the normal at P. And this line L is the tangent at P. Then we'll write down slope of tangent and normal. So given a curve, say this is x-axis, say this is y-axis. If you want to write down the slope of tangent and normal, say at some point P, you have drawn a tangent, which makes an angle theta with the positive direction of x-axis measured in anti-clockwise sense. The slope of the tangent is tan theta. M at P is tan theta, and that is equal to derivative for the curve, dy by dx for the curve at that point P, x1 comma y1. If the point has coordinates x1, y1, derivative at that point will give you the slope of the tangent. So if the curve is named as some y equal to f of x, we know that dy by dx can be written as f dash of x, and when you substitute x as x1, it becomes f dash of x1. So at any point P, x1, y1, if you draw a tangent, the slope is f dash of x1. And similarly, if you draw the normal at the same point, perpendicular to this tangent. So let's say the tangent meets here in T, normal meets here in N. Pn is called normal, and the slope of the normal at P, if you have to write down the slope of the normal at P, what do you write? Minus 1 by slope of the tangent at P. And that is minus 1 by f dash of x. So if you know tangent slope, since tangent and normal are perpendicular, the product of the slopes is minus 1. So normal has a slope minus 1 by f dash of x1. Or you can even leave it as dy by dx also, if required. So this is for tangent and normal slope. And then if you have to find equation of tangent and normal, a general method which is even used for circular, parabola, ellipse, hyperbola also. We can use this method always to find out tangent and normal. So whenever you have to find out a tangent and normal equation to any curve, So if you want to write down tangent at x1, y1, same diagram what I've drawn earlier, so I need not draw it again. So if you want to find out a tangent at p x1, y1, so you can just use point slope form. Y minus y1 equal to slope of the tangent into x minus x1. So we can use the symbol m for tangent slope. And what is m here? We already wrote the derivative at that point, f dash of x1. And if it is a normal at p x1, y1, you can just use the same point because both pass through same point. But you have to use capital M as the normal slope, and capital M is minus 1 by small m. And that is nothing but minus 1 by f dash of x1. So with the help of this, you can find out the normal. Now, suppose you have to find out intercepts of a tangent. Intercepts of a tangent, you may require it in some questions, of a tangent on the coordinate axis. So how do you find the intercepts of a tangent on the coordinate axis? If the tangent is y minus y1 equal to m into x minus x1, so put y equal to 0, then you'll get minus y1 is equal to m into x minus x1. You'll get x-intercept from here. So you will get x minus x1 as minus y1 by m. So x is equal to x1 minus y1 by m. So this is the x-intercept. And when you write length of the intercept, you can write a modulus. And similarly, if you put x equal to 0, you'll get y-intercept. So if you put x0, y minus y1 equal to m into 0 minus x1, y equal to y1 minus mx1. So what you got here is nothing but the y-intercept. So there is nothing to by heart, only the method I'm just explaining. Here you need not remember it. You can do it directly in questions. And same method you can do it for normal also. Same method you can also do it for normal. So if you have to find intercepts of normal on coordinate axis. Intercepts of normal on coordinate axis. So what is the normal equation? Y minus y1 equal to capital M into x minus x1 or minus 1 by m into x minus x1, where small m is the tangent slope. Okay. So in this, put x equal to 0 to get y-intercept. And just put y equal to 0 to get x-intercept. So I'm not calculating. Just will leave it like this. So this is the method to find out their intercepts. And some questions will be framed based on finding sum of the intercepts or sum of squares of intercepts or area of triangle formed by the tangent and normal with coordinate axis. All such questions you can do if you know how to find the intercepts. So right now, this much knowledge is enough to start with. And in between, I'll do a few concepts. So we'll start with the questions now. Right. So all of you try the first question. The normal to the curve at 1, 1 satisfies which of the options? So some random curve you can draw. They're saying normal to the curve. This is the tangent, but they're talking about the normal. Okay. So how do you draw a normal? The normal meets the curve again or not, we have to check. So for example, this is the tangent and this is the normal. If the normal meets the curve again at some point, some random curve I've drawn. So the normal meets the curve again at some point Q. So does this happen or not? Is it meeting or is it not meeting is the question. So just what you have to do, P and Q are the points on the curve as well as the normal. That means when you solve the normal and this curve, you are supposed to get their coordinates. So first find the normal. To find the normal, what are we supposed to do? Differentiate the equation of this curve first, you will get tangent slope. So what is the derivative of x square? 2x, and here you have to apply uv and direct differentiation here. This is one method. Other method is whenever you have an implicit function of the form f of xy equal to constant, what is the formula to find derivative? Minus of partial derivative of f with respect to x by partial derivative of f with respect to y. And whenever you do partial derivative with respect to x, we treat y as constant. When you do partial derivative with respect to y, we treat x as constant. So using this directly, dy by dx equal to minus of partial derivative of x square with respect to x is 2x. And when you differentiate 2xy partially with respect to x, 2y is constant. Derivative of x will be 1. And 3y square derivative is 0. Divided by, if you write dou f by dou y, partial derivative with respect to y. For x square, derivative is 0. For 2xy, what is the derivative? You can write, you are differentiating with respect to y. So y is variable, x is constant. So 2x you write as it is, y derivative is 1. 3y square, it is 6y. So once you got this, they're asking at 1, 1. So what is the derivative at 1, 1? You have to find out. So then put x and y as 1 in this. Then this will give you minus of 4 by minus 4, putting x and y both as 1. So this will become plus 1. So by putting x equal to 1 and y equal to 1, numerator is minus 4. Denominator is also minus 4. So you'll get plus 1. This is the tangent slope. But I actually want to find normal equation and solve it with the curve. So normal slope is therefore minus 1. And therefore, what is the normal at that point? So normal at 1, 1, if I want to write down, it is y minus 1 is equal to slope of the normal. We already know minus 1 into x minus 1. So this is same as x plus y equal to 0, I think. So now they are saying this cuts the curve. The normal to the curve cuts it at some other point. Is that true or not? And is it is in which quadrant?
Sir, is it x plus y equal to 2?
2, sorry. Yeah. It is 2. X plus y equal to 2. So you solve this with the curve equation. What is the curve equation? X square plus 2xy minus 3y square equal to 0. Then one of the points is already known, 1, 1. The other point you can find by solving. So if you put y value as 2 minus x, x square plus 2x into 2 minus x, minus 3 into 2 minus x whole square equal to 0. You can solve this and get the roots. So we'll get x square plus 4x minus 2x square minus 3 into 4 plus x square minus 4x. So solve this. One of the values of x, you'll get 1 again. And one more value you'll get. That will be the other point that you require. So if you open the brackets, we have x square minus 2x square minus x square plus 4x. Open the brackets here, you'll get minus 12 minus 3x square plus 12x. So what is the same as minus 4x square plus 16x minus 12 equal to 0. Dividing with minus 4, you'll get x square minus 4x plus 3 equal to 0. X minus 1 into x minus 3 equal to 0. So x equal to 1 or 3. And if x is 1 or 3, since you know that x plus y is 2, you can say for x equal to 1, y is 1. For x equal to 3, y is minus 1. So that means one of the points where it is cutting is 1, 1 anyway. You have drawn the normal at that point. What is the other point where it is cutting? 3, minus 1. So what do you conclude? Normal cuts the curve again at which point? 1, 1 was the original point which was already there. So 3, minus 1. And that is in which quadrant? Fourth quadrant. So this will be in fourth quadrant. So if you go back to the options, so this meets the curve again in fourth quadrant. So fourth option is the answer. So try the second question. Yeah, so for this question, we are given f of x as an inverse trigonometric function. A normal to f of x at x equal to pi by 6 passes through which point? So first thing, we'll have to simplify the function and then we have to find the normal after that. So how do we simplify this?
Multiply by 1 plus sin x.
We have to first rationalize this. This part, if you rationalize, so you have to multiply and divide with 1 plus sin x in the numerator and denominator. Multiply with 1 plus sin x, 1 plus sin x in denominator also. Then in the numerator, you have two factors, same, and the root is there, so it will become 1 plus sin. In the denominator, you will get 1 minus sin square x, which is cos square x.
The root is there, so cos x.
So is this better or anything else is better? So there is another way of doing it that would be better, I think, because you actually have to make a perfect square, then it will be better. So instead of doing rationalizing, the alternative way is write that 1 as cos square x by 2 plus sin square x by 2. This is better. Plus 2 sin x by 2 cos x by 2. And denominator, same thing with a minus cos square x by 2 plus sin square x by 2 minus 2 sin x by 2 cos x by 2.
Sir, you will get the same?
No, the previous one will give a different answer. This is in half angles. No, cos x by 2 plus sin x by 2 whole square by cos x by 2 minus sin x by 2 whole square. In the previous case, you could have got something like secant plus tan or something. But I want something in tan only. So when you convert like this, it becomes a plus b whole square, a minus b whole square, and root and square, if you cancel, get a mod. So cos x by 2 plus sin x by 2 by cos x by 2 minus sin x by 2. So till here, it's only trigonometry part. After that, only derivative part will start. So once you got this, they gave an interval that x is between 0 to pi by 2. So that means x by 2 is between 0 to pi by 4. And we know that between 0 to pi by 4, cos is more than sin. So this is required when you open the modulus. So when you open the modulus, so this value can be written as numerator anyway will be positive only because the angle x by 2 is an acute angle. So both are positive, it's positive. In the denominator, when you open the mod, if cos is bigger, you will write cos minus sin. If sin is bigger, you will write sin minus cos. So that is important. That's why they gave the interval. So based on this interval, you got x by 2. And between 0 to 45, cos is greater. Between 45 to 90, sin is greater. So cos is greater. So when you open the mod, it will be cos x by 2 minus sin x by 2. And this is same as you divide with cos, it will become 1 plus tan x by 2 by 1 minus tan x by 2. And that is nothing but tan of pi by 4 plus x by
5
2.
by 4
Plus x by 2. Right. And what was the interval for x by 2 we had? 0 to pi by 4. Now I want pi by 4 plus x by 2. Add pi by 4, become pi by 4 to pi by 2. So why is this interval required again? I'll tell you. So when you want to now find out the function, we had inverse function outside. We had an inverse function, tan inverse of this value. Tan inverse of this value, tan inverse of tan of pi by 4 plus x by 2. So when you're calculating the value of this inverse function, when can you cancel tan inverse of tan? You write this as x only when
minus
x
pi by 2
belongs to
to
minus pi by 2 to pi by 2 or any of the subsets of it also you can write. So to cancel tan inverse and tan, this angle should have an interval which is within that. And you clearly see the angle has an interval pi by 4 to pi by 2, which is a subset of that. So you need to check that before you cancel and write pi by 4 plus x by 2. So till here, actually, it's a question of trigonometry and differentiation. After that, only application of derivative part. So f dash x is equal to 1 by 2. Differentiating, pi by 4 will have 0, x by 2 will have derivative 1 by 2. And you want the normal at x equal to pi by 6 passes through which point? So if you want to find the normal at x equal to pi by 6, so at x equal to pi by 6, what is the value of the function? We got the function as pi by 4 plus x by 2. That is y equal to pi by 4 plus x by 2. So this is pi by 4 plus what will be x by 2? If you divide by 2 here, it is pi by 12. So this is y value. You want to find the normal here. And what is the slope? We got the slope as 1 by 2. And that doesn't depend on x actually. So f dash of pi by 6 also will be 1 by 2. This is tangent slope. What will be the normal slope? Reciprocal of this with a minus. So then equation of normal, if you have to write down. So before that, what is the LCM 12? So 4 into 3, you'll get 3 pi plus pi. 4 pi by 12, I think this is pi by 3. This is pi by 3. 15 and 45, no, yeah, pi by 3. So what is the normal at this point? So the normal at the point where x is pi by 6 and y is pi by 3 is given by y minus y1. So y minus pi by 3 equal to slope into x minus x1. Slope is half into x minus pi by 6. They didn't ask the normal equation. They said normal always also passes through some point. So which point will satisfy that you have to find. Yeah, you were saying something?
minus 2 will come, sir, not 1 by 2.
Sorry, I had to write minus 2 there. Correct. Yes. So this is the normal slope. We are not finding tangent, we are finding the normal. And just in the options which will satisfy this, you need to check. So you can finish writing and check which option will satisfy this because they said normal passes through which point. So you have to put this point and verify which point will satisfy the normal equation. Passes through 0, 2 pi by 3. So you can conclude that it passes through 0, 2 pi by 3. I'll just show the previous slide also if you have not finished. Before this one. So first option is the actual answer. Satisfying the Okay, this was question number 2. I hope all of you finished. Then try the third problem. The normal to the curve at the point where the curve intersects y-axis passes through. So where are we drawing the normal? At the point where it cuts y-axis. So how do you find the point where it cuts y-axis? It cuts y-axis at x equal to 0. So if you put x equal to 0, you'll get y into -2 into -3 equal to 6. So this will give us y value as 1. So that means the curve cuts y-axis at 0, 1. Curve cuts y-axis at 0, 1. And we want to find the normal at this point. And to find the equation of normal, first we have to know the slope of the normal. Point is known, but you need the slope. So from this curve, what is y value? X plus 6 by, if you multiply x minus 2 and x minus 3 and write, it is x square minus 5x plus 6. So you find out the derivative using quotient rule. Dy by dx equal to denominator into derivative of numerator, which is 1, minus numerator into derivative of denominator, which is 2x minus 5, differentiation of denominator by square of denominator. And once you got this dy by dx, you want to find the normal at 0, 1. So first find dy by dx at 0, 1, you'll get tangent slope at 0, 1. So if you write the value of dy by dx at 0, 1, what do we get? So x is 0 and y is 1. So wherever x is there, you put 0, you'll get 6. And here 0, 6 here, minus 5 here. By, if you put x as 0 here, you'll get 6 square, 36. So in the numerator, we have 6 common. 6 into 6 only, I think. Okay, that is 1 actually. So if this is 1, tangent slope is 1. So normal slope is -1. So what is the normal at 0, 1? Y minus y1 equal to slope into x minus x1 you can use. This is capital M, this is small m. So y equal to minus x plus 1, or it would be better to write everything in LHS, x plus y equal to 1. So it passes through which point? So C option will satisfy. So x plus y is 1 only in that case. So it passes through 1 by 2, 1 by 2. There can be many other points through which it will pass, but among the options 1 by 2, 1 by 2. Because x plus y is 1 for this. So this is again a simple question. Only thing they are checking differentiation also here, quotient rule, whether you know it or not, they are checking. So that separately they need not ask a differentiation question. Here itself both are covered. Okay, write this.